Dear friends, good morning. In the last class, we discussed about the histamine and histamine synthesis and classification of the antihistaminic drugs and the difference between the first generation and second generation in my part 1 video. Now we are discussing about the various drugs which will be comes under in the H1 antagonists. I will start with the diphenhydramine. See the diphenhydramine especially when you will see the structure of this diphenhydramine, it will be having the dibenzene, that is the 2-benzene attached to the methoxy group because it is the ether form. This drug particularly it is present in the ether form. Ether form means you might be know ROR. Generally where you are observing that ROR, when you will be see this, here you are observing this R and this is the O and this is the R because it is having the ether linkage. Okay, and it is attached to the methoxy group. Okay, here OCH3. This is the methoxy group OCH3. The normal chain it is the same. It will be having the ethyl chain in the structure. Okay, then as well as it will be having the dimethyl amine group. Okay. Now, when we will be discuss about the synthesis of this particular drug, you can see the synthesis of this one. The synthesis it will be start with the diphenyl bromomethane. This is the diphenyl bromomethane. In this structure, you might be observing in this case, what happening here exactly means, it will be undergoes the condensation with the dimethyl aminoethanol. This is the dimethyl amino group. Okay, dimethyl amino group attached to the ethanol. This is the one, this is the 2 carbons ethanol. Okay, now see here how it is going to be synthesized. Here bromine is there. Always bromine, it will be attack on this hydrogen. Okay, then what it will be relieve? It is going to be relieve the hydrogen bromide. It is going out. Okay, in the presence of potassium carbonate, we are using as the salt, that is the catalyst is the potassium carbonate we are using in this case. Then once this hydrogen bromide goes out, it is going to be produce the diphenhydramine. Simply here you might be observing in this case exactly here diphenyl group, diphenyl attached to the methyl, here also diphenyl attached to the methyl, then it will be attached with the oxygen. That oxygen is here, this is the oxygen, remaining thing is the here 1 carbon, here 1 carbon. Okay, remaining thing is the same. That's why what it is going to be relieve here, it is going to be relieve exactly here, it is leaving the bromine as well as this hydrogen. It goes out in the form of minus HBr. Okay, to produce the diphenhydramine. The mechanism it will be remain same. It is going to be bind with the H1 receptors. Okay, to produce as the antagonist effect on the H1 receptor, then it will be blocks the H1 receptor. Then whatever it might be allergens, it is going to be released in our body. That allergens it is going to be block. It is going to be stop. That is the mechanism. When comes to the uses, we might be know it is used for the particularly irritating eyes, that red eyes, water eyes, as well as the sneezing also it is going to be stop. Okay, along with the various type of allergies. Okay, then along with it is also useful in the relieving the cough. Okay, these are the main uses of this particular drug, that is the diphenhydramine. This diphenhydramine is very important. This drug is very important for you. Okay, while you are studying. The next drug is the doxylamine succinate. This doxylamine succinate, it is almost similar to the diphenhydramine. When you will see the diphenhydramine similar, here diphenyl methoxy group is there, but in this case Here also diphenyl, but one of the phenyl it will be attached it is having the heteroatom. That is the difference. The another case is that it is having the methyl group extra. Then if you write the diphenhydramine structure, you will be come to know easily. We can write like this also, this structure. I will write, just see in the easy way. This is one phenyl. Here you might be observing here one carbon, or you can write this phenyl group downside. This is the phenyl. Two phenyl groups came. One is having the heteroatom. Then here what you are observing in this case means extra thing is that here it is having the methyl group that is not present in the diphenhydramine. Then the remaining thing is same. Remaining thing is the same means it's like it is also having the ether linkage. Along with that it will be having the ethyl group, because one carbon, this is the two carbons ethyl group, then it will be attached to the dimethyl. This is the dimethyl amino. Okay, ethyl group, exactly it is similar to the diphenhydramine. The difference is this is the different. The another one, what is different? This is different because these two are not there, means this heteroatom is not there in case of diphenhydramine, but in this case heteroatom is there. Diphenhydramine, this methyl is not there, but in this case methyl group is there. Remaining thing is side chain is a very similar side chain, it is similar like that earlier drug diphenhydramine. This is also useful in the same in the treatment of allergy and as well as the hay fever that is caused by the allergy only, and also it is useful in the cold also and various allergies also, and it is helpful in the runny nose also, and it is also helpful in the watery eyes also. Okay, whatever irritation of the eyes also it is going to be reduced. Then clemastine fumarate. The clemastine fumarate, one thing only the difference we are going to be observed, it is similar to the diphenhydramine. See, exactly similar to the diphenhydramine. But here what is difference here? The difference is this, where it will be having the pyrrolidine methyl pyrrolidine ring. This methyl pyrrolidine is not this is not present in the earlier drugs, but it is present in this clemastine fumarate. How it will be the same? The structure you can write, one phenyl group is upper side. Sorry. One phenyl group is upper side, group is downside. Then here you might be observing one of the phenyl group, it will be having the chlorine in their structure. Then here same, what it will be having, methyl group it is having here. The methoxy group it is there, methyl, this is the oxy, that's why methoxy. Then ethyl group is very common. But here only the thing is different. Instead of attaching to the nitrogen here, it is attaching to the pyrrolidine. Means here one more carbon it comes extra here. Here one more carbon. Along with that, it forms the pyrrolidine structure. Means one extra carbon is present. Okay. What is that extra carbon here? This is the extra carbon here. Along with that it will be having this particular structure, that is the methyl pyrrolidine. Okay, then it is also, when comes to the uses are same, like a cold and allergies and runny nose with the fever, whatever it might be, sneezing, runny nose. Okay, all those things like the earlier drug, it will be going to be relieve even urticaria also, that is itching also. Now you can see the triple the triple also, it is the similar structure, but the thing is that here the difference in this structure is this methyl group is extra here. It means instead of phenyl group, here it will be having the benzyl group. Benzyl group means you can see that. And another thing is that here it will be having the extra nitrogen, triple nitrogen. That's why it is called as the tripenylamine. Here one nitrogen, here one nitrogen, and here one nitrogen. Total how many? Here it is having the 3 nitrogens. That's why it is called as tripenylamine. Means triple amine. It is having the triple amine. Remember the structure. It is having the triple amine. That's why what it is called? It is calling as the tripenylamine. Okay. If you remember this, it is very easy to write the structure. It is not that difficult for you. Here you can see how you can write the structure. Instead of what we are doing, instead of carbon, it is attached to the nitrogen. One nitrogen, it is having the pyridine structure. This one is the pyridine. Okay. Then another side, it won't have the phenyl directly. It is having methyl group first. Then after that, it will be attached to the phenyl. See, the extra thing is what? This methyl group. Okay. Then that will be attached to the, again, the ethyl group. That ethyl group having the link with the dimethyl. Okay. It is not coming in the ethoxy group. That is the methoxy. It won't have any methoxy. Instead of, it will be having the nitrogen. Means diaminoethyl side chain is present. See, this is diaminoethyl side chain. It is contained. Okay, and it is having the 3 nitrogen. That's why it is called as the tripenylamine. Easily you can write the structure now. Okay, no need to be worried about this structure. Now comes to its uses. Its uses, tripenylamine also same uses. When the histamine produces in our body, that is the by the natural process, that histamine it is going to be prevent by using this tripenylamine. Okay. Then same uses it will be how all this H1 antagonist majority cases. Remember, if you don't, means if you are confusing in the writing the uses, means remember the first use is the same. It is used for the allergies, that may be the nose allergy, that may be the other allergies, that may be the eye allergy, whether it may be the, you might be no itching of the body. All those things you will be discussed here. Means all those are the uses, because due to allergies only rashes will be causes, due to allergy only itching will causes. Is it right or not? That's why the uses will be remain same. But if you want to remember the structure of this one, very easy to remember the structure. It is having the 3 nitrogen, means 3 amines. That's why it is called as the tripenylamine. Mechanism will be same. Mechanism, it is going to be block the particularly H1 receptors. Then the whatever the allergens will be there, they are not going to be produced in our body. Next, the piperazine derivatives it will become. The piperazine derivative means they will be having the structure that is called as the piperazine. This is the piperazine structure. When you will be see, here it is present. See, piperazine. Here other side lining is there, means here it will be having the methyl group. This is the bromide, diphenyl. Diphenyl methyl bromide. Okay, the name for this one, diphenyl methyl bromide. It is react with the methyl piperazine. Remember that. React with what? Methyl piperazine. Same in the presence of alkali here. And it is going to be relieve the hydrogen bromide. This one also. Now this hydrogen combined with this bromine, then it will be relieve this HBr to produce this. Means here it will be having the diphenyl methyl. The diphenyl methyl, it is going to be attached with the what? Piperazine, methyl piperazine. This is the cyclazine. It is belongs to the derivative of the piperazine. Okay, this also it will be having the same uses, like it is irritation also, allergies also, that may be the nose allergy, eye allergy. But main thing is that it is very useful because it is having the piperazine in the structure. It is useful to prevent the nausea, vomiting, dizziness, motion sickness, vertigo. Vertigo means we will get the irritation of the body and our brain will become dull, will feel little bit dullness. Not only that, it is useful as the useful in the means it is used for the nausea, especially after the general anesthesia. Okay, because it is developed from the opioids. Okay, but it will be having little different uses. uh, like it is used in the nausea, vomiting, dizziness, motion sickness, and vertigo. This vertigo it is causes due to the allergy. It is causes due to the allergies. Okay, these are the uses of this. Synthesis easily you can write, and another thing is that it is similar to the diphenhydramine, but only the thing is that it is having the piperazine in their structure. Now you can see the chlorcyclazine. Chlorcyclazine, it is exactly similar to the cyclazine. But what is the difference it will be having? Only it will be having the chlorine here para position. Here only it is having the chlorine group. That's why this chlorcyclazine is the chlorine extra. Okay, that is the reason it is called as the chlorcyclazine. It is attached to the hydrosalt of the hydrochloric acid. Then we might be no uses are same. It is useful in the uteric area, means itching, means various type of pruritus and various type of rhinitis, and as well as it is also before this drug we will be discuss cyclazine. It is having it is going to prevent the vomiting, it is going to prevent the nausea. That's why it is also same category it will become, because only the difference it will be have the chloro group. Okay, that's why it is also having the histaminic properties. Now you can see next meclazine. This meclazine is very important drug, uh, because most of the time we are using for reducing the light headache this meclazine. Okay, and you might be know especially this meclazine having the basic structure like the chlorcyclazine. See this structure, it is similar to the chlorcyclazine, because here it what it is having, chlorine it is having. Instead of here it is having the methyl group, then it will be attached to what, dimethyl phenyl. Here this is the dimethyl phenyl group, it is attaching here. See, here one methyl, here one methyl, this is the phenyl. Okay, it is attached to dimethyl phenyl group. Or in word, if you one word if you want to say means easily, what is the difference between chlorcyclazine, this one means only the difference is this. What is this extra? It is called as the toluene. Toluene is extra when you will be see the chlorcyclazine. Okay, that's why if you remember one structure, see you can write the numerous structures, number of structures which will belongs to the same class. Here also you can see the synthesis of this particular drug of this meclazine. Initially it is going to be react with the acetyl piperazine. Okay, this is the acetyl piperazine. Acetyl piperazine, here what happens exactly in this case means, just you can see this hydrogen is there, hydroxy group is here, hydrogen is here. Both will be during condensation it goes out in the form of water. That is one thing. Okay, because here we are using the thionyl chloride SOCl2. as the catalyst. Now you can see then what it will be going to be produce. It is going to be produce the derivative of the chlorcyclazine. See here, it's look like the chlorcyclazine. What is the difference in this case? You are going to be observed. Difference is this group. Okay, COCH3. Acetyl group only the difference. This acetyl only the extra. When treated with this acetyl piperazine, it produces the acetyl derivative of the chlorcyclazine. Okay, remember that. Then after that it is undergoes the process of the acid hydrolysis. What it is called? Acid hydrolysis. Why we are using this acid hydrolysis process? The reason is very simple, to remove this particular group that is called as the acetyl group. Okay, we are using this process. Then see here what happened in this case. In the next step, it is going to be react with the, I will show just a second. Just see here what happened. This acetyl group is going out. That is COCH3. Okay, it is going out. Okay, then what will be remain here? Nothing is there means what will be remain here? Here it will be, it loses this entire moiety, and here what it will be going to be get? I will write the structure here, like here one phenyl, here one phenyl, here only the difference, here it will be get the hydrogen. Now what happened? This hydrogen combined with this chlorine, then what it will be loses? It is loses the acetyl, along with it is going to be relieve the hydrochloric acid. Then what it will be produces after losing this? It is going to be produce the meclazine. How it is going to be produce meclazine? See here, one phenyl, para position what it is having? Chloro. Then another phenyl. Okay. Then methyl attached to the piperazine. This piperazine attached to the one side methyl. That methyl is here, just see. Here that methyl. This is the methyl, same methyl here. I will write. Now see here what it will be going to be attached. This methyl group is going to be attached. That CH2. Okay. That CH2 going to be attached to what? Phenyl ring. Like this. Okay. That phenyl ring, along with that it will be having the another methyl group. This is the structure of the meclazine. Okay, this meclazine also like a chlorcyclazine. It is also useful for the motion sickness. It is also useful for the vomiting. Okay, nausea, and as well as the along with that it is used in the headache, light headache also. Okay, then we might be know it is useful in the vertigo also. Okay, the loss of the balance of our body, that's why we'll feel very weak in this condition. Okay, and as well as the whatever it might be infection will be there of the inner ear, that also it is going to be prevented. Then buclazine. Buclazine like a meclazine, same structure. What is the difference here? This is tertiary butyl group. This group attached here. This is called as the tertiary butyl. Extra is what? Tertiary butyl. Butyl means same structure like meclazine. That's why butyl plus meclazine. Then what it will be called? Buclazine. Okay. I think you will be remember this structure easily. This drug also, particularly it is used in the treatment of vomiting. It is also useful in the vertigo conditions. Not only that one, in the nausea, vomiting, dizziness, okay, motion sickness, all they are going to be treated by using this particular drug. Now you can see very important drug that is called as the chlorpheniramine. Okay, diphenhydramine, chlorpheniramine, these both the drugs are very important. Okay, but both are different, because diphenhydramine it won't contain this pyridine, but chlorpheniramine it contain the pyridine. But here the chain it will be remain same. What chain? Instead of ethyl it will be having the propyl. Propyl means how many? Here it will be having the 3 carbons. Okay, between the diphenylic group and as well as the of this nitrogen. That is the structure of this chlorpheniramine. Okay, the chlorpheniramine you might be know. Then when you will be see the synthesis of chlorpheniramine, the starting material required for this one, this is para-chlorophenyl. This is the para position, chlorine is there, para-chlorophenyl, this is the phenyl. This is called as the acetonitrile. Okay, this is required as the starting material along with the pyridine. Then it will be undergoes the particularly reduction process. Reduction means here it is going to be remove both. Here cyanide group it is going out. This copper is used as the reducing agent. Reducing agent. Okay, it is by reduction it is going to be remove the cyanide group in the form of HCN. It is going out, it is going to be relieved. Then what it will be remain? Only the thing remain this carbon, this group only it is going to be remain. Okay, then it will be produced as the derivative intermediate, which will be contain the pyridine and chlorophenyl group attached to the methyl linkage. Methyl linkage means here you might be know nothing is there, here means 2 hydrogens are there, extra hydrogen is there. Now this hydrogen, this combined with this chlorine, then it will be relieved in the form of HCl, because this is the side chain. Okay, dimethyl, already 1 carbon is here, 1 carbon is here, 1 carbon is there. Okay, 1 carbon it is present in this structure, 1 carbon. Then another 2 carbons here, second carbon and third carbon, means total how many carbons? 3 carbons. Okay, 3 carbons, 2 carbons from the dimethyl amino ethyl and 1 carbon from this particular starting material. Then total 3 carbons. Okay, see here, this is 1 carbon, this is 2, this is 3. See, this is 1 carbon. Okay, this is 2, this is 3. Here you can see. Then finally produces the chlorpheniramine. This is very important. Okay, because this particular drug, it is most useful in case of allergies and common cold. Okay, not only it may be useful in the rashes which is caused due to allergy, and the eye infections like the watery eye also, and itching also of the eye, and runny nose, cough, sneezing, various itchy process of the eyes, nose, throat, skin, all they are going to be treated by using particular this drug. That's called as the chlorpheniramine. This one also belongs to the class of H1 antagonist. Remember, it is also belongs to the class of H1 antagonist. Then next drug is the triploridine. Triploridine, not the triplenamine. Okay, triploridine is different and triplenamine is different. Triploridine. Okay, in this triploridine, the structure it is little different. Here also it is belongs to the propyl, but 3 carbons. But the thing is here, what it will be having? It is having the double bond here. It is having the double bond. That only the difference. Okay, and triploridine means it will having the pyridine, and as well as it is having the pyrrolidine, and it is having the 3 rings. See, 3 rings means triple rings. Remember that. Plus pyridine plus pyrrolidine. All together what it is called? Triploridine. Triploridine. Okay. Triploridine. Remember the drug. It will be having the double bond. It is having the 3 carbons. Okay. Not only it is having the 3 carbons, along with that what is having in the structure? Pyridine is there, pyrrolidine is there, and along with that what it will be having? Propene is there. Along with that it is having the 3 rings. Okay, then it is also useful in the allergy as well as the common cold, as well as the runny nose and sneezing and itching of the eyes and itching of the nose. Okay, the whatever it may be the causes the symptoms due to the allergy, all they are going to be treated. This synthesis of triploridine, it is there in the syllabus and it is very important for you. Here observe very carefully. Okay, this is called as the methyl acetophenone starting derivative, because it is having the methyl group, along with that it is having the acetophenone, means to the acetophenone. When you will be see, this is the structure of acetophenone. What is there? Methyl group is there at the para position to acetophenone. That's why it is called as the methyl acetophenone. See the structure of the triploridine. Okay, when you will see the structure of the triploridine, okay, I can draw the structure of the triploridine first here. What is having? Nitrogen it is having here. then another phenyl group which will be attached to the methyl group. Then we might be no carbon and another carbon along with the another carbon which is attached to the pyrrolidine. Here it is having the double bond in their structure. Okay, this is the structure of the tripyrrolidine. See, methyl acetophenone. Here what happening here exactly? We are treating with the formaldehyde. What is the use of formaldehyde here means? Formaldehyde introduces this carbon. Okay, this carbon coming from the formaldehyde. From this, which carbon is coming from this? This carbon. Okay. This carbon is coming from the formaldehyde. This is the formaldehyde. Then it is attached to the pyrrolidine already because this hydrogen. Okay. In this case, in the presence of formaldehyde, it will be introduced as the extra carbon, this one, and it will be attached to pyrrolidine here. This pyrrolidine attached here. This extra carbon coming from the this one, extra carbon. Remaining thing is same. Now it will be react with the bromopyridine. Okay, this bromopyridine, when it will be attached particular on this compound here, bromopyridine. Okay, bromopyridine, where it will be attached? Just see here in this case. Here we are using the lithium. With the lithium, it undergoes the reduction. Okay, one more step here it is there. It will be undergoes the reduction means what? Particular this structure here the methyl, due to reduction, here it will be converted to the here it will be undergoes the reduction, this process reduction. Reduction means introduces of the hydrogens. Nothing is there means here how many hydrogens are there? 2 hydrogens are there like this. Okay, by the reduction 2 hydrogens are introduces here. Then remaining thing will be the same. Here it will becomes CH2 due to what? Due to this lithium. Okay, then it will be reduced as remaining thing will be the same, CH2, then CH2, then CH2, and it will be attached to the pyrrolidine. Okay, attached to the pyrrolidine. This is the pyrrolidine. Okay, then what happened now? This bromine react with this hydrogen. These electrons of this hydrogen, whatever the electrons are there, helpful for the formation of the double bond here. Here, these electrons will move here. Then what it is going to be formed? Here you might be observing, it is going to be produce this compound. Okay, loses the HBr, not HCl here, it is wrong. In the presence of acid, HBr, here it loses the HBr. Okay, then loses HBr, then it is going to get the double bond here. Okay, by the relieving of this, it produces double bond here. Then remaining thing will be the same. Okay, this is this compound, and this compound is the pyridine, came from this pyridine. Okay, then double bond, due to this reason here it is forming the double bond, and this is the pyrrolidine, and this is the pyrrolidine. By the ion exchange process, it is going to be separate the triploridine. Okay, one form of the triploridine. Here both cis and trans is there, but here it is going to be produced, that is cis triploridine or trans triploridine. Okay, exactly, this is the synthesis of this. I hope you might be understand. This is the synthesis of the triploridine, very important. Then phenindamine tartarate. Why it is calling as the phenindamine? See here, it is form of the indole. It won't have the nitrogen, but it is look like the indole. Okay, then you can see here, it will be attached to the parahydropyridine, methyl parahydropyridine. Okay, then you can see here it will be attaching the phenyl group at the para position. When you see the structure of this, it is called as the phenindane, that is the phenyl, and look like the indole. Okay, this is the phenyl and this look like a indole. This is called as the phenindane. Attached to what? Pyridine, that is parahydropyridine. That's why it is called as the phenindamine. This is the tartarate in the form of salt. That's why it's called as the phenindamine tartarate. This also, it will be having the same uses. It is used in the allergies, various allergic reactions. Okay, along with the allergies of the nose, allergies of the eyes, and other allergies symptoms, it is going to be treated along with the common cold. Okay, like next the drugs are the, we might be know the phenothiazine class. Phenothiazine. The phenothiazine, you might be know, it is the diphenhydramine only. If you remove this particular drug, it is look like this. See, you're seeing. Okay, then what it comes here, extra thing is the, here in between these two, what it will be attached here, sulfur is attached here, exactly sulfur. That's why it forming the phenothiazine derivatives. Now see, when it comes to the phenothiazine synthesis, very simple. We are taking the phenothiazine, okay, then it will be treated with the side chain. Side chain, what it is there in the side chain? You might be observing here. This is the 1 carbon. This is the 2. This is the 3. Then what we are writing? 1 chloro means first position chloro. Then this is NN dimethyl. NN dimethyl. 3 carbons. These 3 carbons. 3 carbons. It is called as the propane. Then at the second position, what it is having? Second position amine is there. That's why it is called as the 2-amine. It is react with the soda-amide. What it is called? React with the soda-amide. This reaction also called as the Chichi-Bobino reaction. Chichi-Bobino reaction. Okay. Then it is going to be here particularly take away the hydrochloric acid to produce the promethazine. It is combination with the salt to produce the promethazine hydrochloride. It is also same various motion sickness and allergies, vomiting, nausea, and the allergies of the nose. All those things going to be prevented. The next one is the methylazine. Here this is the methylazine means phenothiazine. Phenothiazine along with the methylazine. Methylazine means you might be observing here this structure. That is the dimethyl pyrrolidine. Okay, dimethyl pyrrolidine. It will be attached to here one nitrogen and here one nitrogen. Okay, there is the 2 nitrogens, this one and this one. It is called as the diazine. That's why it is called as the methylazine. It is also useful for the itching eyes and itching of the nose and as well as the common cold, okay, runny nose and various allergies, even the upper respiratory tract allergies also it is going to be treated by blocking the H1 receptors. Okay, this is the cyproheptadine. Heptadine, see heptadine. Heptadine means what? Here you might be observing heptadine, 7-membered ring. 7-membered ring, heptadine attached to the what? Both the phenyls. This is one phenyl. This is one phenyl. That is called as the biphenyl. Attached to here heptadine means heptane. This is the cycloheptane. Cycloheptane plus biphenyl plus piperidinal. That's called as the methyl piperidinal. Methyl piperidinal. Okay, it is called as the cyproheptadine. Same, it is also useful in the itching, various allergies. Okay, along with the various allergies reactions, it is going to be treated by blocking the H1 receptors. Okay, and this one is the azatidine maleate. The difference is this one, cyproheptadine and this one. This is the difference what we are going to be observed. That's why it is called as the azatidine. Aza. Okay, aza means what? Nitrogen. Okay, how many nitrogens? 2 nitrogens are there in this case. This is also useful in the common cold and various type of itchings. Okay, then azatolin. Azatolin because it is attached to the imidazole. Okay, and we might be know here the toluene is there. ASA is there. This is ASA. This is toluene. That's why it is called as a toluene. Okay, which will be attached to the imidazole. Okay, that is the 1H imidazole. This is the 1H imidazole. This is also useful in the that is the eye allergies. Mainly they are very useful because we are using in the form of this drug, particularly we are using in the form of eye drops, because it treats eye allergy. All those are the first generation, because all those drugs, all the drugs, first generation drugs, what I told, first generation drugs, sedation effect produces, they produce as the sedation. But what we are discussing particularly, these are the second generation antihistaminic drugs. The second generation antihistaminic drugs we will discuss in the next class. Okay, second generation drugs. Second generation antihistamines. Example is the acrevastin. Okay, this acrevastin also, it will be having the diphenhydramine. This like a diphenyl, but the difference is that it is having the pyridine, means one phenyl is pyridine. Then here it will be having the same again. How many? It is having the 3 carbons. This is in the structure, it is having the pyrrolidine. Okay, it will be attached to what? This is called as the propanoic acid. Is also useful in the particularly in the conjunctivitis infections, means eye infections. It is used along with the various allergies which causes the hay fever, and as well as food allergies also it is helpful, but it won't causes any drowsiness, means it is called as the non-drowsy. Non-drowsy means no sedation. This is the difference between first generation and second generation. Second generation, no sedation. Okay, what we observed, second generation, they are not causes the sedation, but in case of first generation, they causes sedation, but no sedation. That is the difference. Okay, now estamazole. Estamazole, it will be having the basic, it is belongs to the class of benzimidazole. Which class? Benzimidazole. See, benzimidazole attached to the parahydropyridine. Here it will be the toluene. This is called as the 4-fluorotoluene. This is toluene, 4-fluorotoluene. Okay, along with the, it is what is having, along with that it is having the, what it is called, methoxy. Okay, benzene, methoxyphenyl ring is present in this case. This is also second generation antihistamine. It causes no sedation, and it is going to be treat various sneezing, allergies of the eyes. Okay, and any inflammatory conditions of the eyes and other parts of the body, other allergies, they are going to be prevented. Next one is the fexofenadine. Fexofenadine, the difference we are going to be observed, it's look like a diphenhydramine, like a diphenyl group. This one attached to the methoxy, that attached to the piperidine, sorry, piperidine, that is perhydropyridine it is called. Perhydropyridine, this is perhydropyridine. Okay, then what it will be having next, it is having the three carbons. Okay, which will be attached to the benzene, as well as the, here you might be observing this side chain and this hydroxy group. This called as the fexofenadine. This also useful in the various type of allergies. Desloratadine also, it is having both the groups. Pyridine also it will be having, perhydropyridine also it will be having. Des means dipyridine. Okay, and loratadine, the difference in the desloratadine and loratadine is very simple. In case of desloratadine, you might be observing this particular groups, chlorine is there, here pyridine is there, chlorophenyl is there, but only the thing is here ester, ethyl ester is extra. Okay, in desloratadine, no ester, but in case of ester, this one, this also, okay, allergy which is caused by the dust and other things, sneezing, runny nose, itching of the eyes, itching of the ears, all they are going to be treated. Now important drug is the citrazine. Okay, in the citrazine it will be having the diphenyl methyl group. This is the diphenyl methyl. Diphenyl methyl attached to the piperazine, which is attached to the side chain here. Okay, then see here in this case particularly, what exactly it is going to be happen, this is the ethoxy acetic acid. Okay, this is called as the ethoxy acetic acid. When you see the citrazine present in both the forms, it means S form, R form, combinedly they will be called as the citrazine. Okay, combinedly it is called as the citrazine. But if it will be have only the R form, means like this here, only the R form, this is called as the levocitrazine. R form only. But if it will be have both R and S form, that will be called as the citrazine. R and S form, it is called as the citrazine. Why it is S form, how it will be, just taken when you will be see the structure, you will be come to know. Okay, what it will be, Just see here, give the priority for this. Nitrogen first priority. This is the second, because here it will be having the chlorine, that's why second. This is the third priority group. This is the third priority group. This is the fourth. Then draw the arrow mark 1 2 3 like this. 1 2 3 clockwise. Clockwise means what it will be? R form. But this hydrogen, what you are seeing, this hydrogen present on the wedge bond. See here, hydrogen present on wedge bond. That's why R becomes S. That's why it is called as the S configuration. In this case, you can see 1, this is the 2, this is the 3, this is the 4. Then how we are drawing? Clockwise like this. But hydrogen, in this case, just see, hydrogen present on dotted bond. That's why R will be remain R form, no change. That's why it is having the R configuration, this one having the S configuration. Both they will be having the same uses: allergies, hay fever and nose allergies, and different types of sneezing, and the other allergy, body allergy process, and common cold. All those things are going to be treated. But citrazine, it will be having both. Both means what? R form as well as the S form. Both the isomers, stereoisomers are present, S form and R form. Combinedly, they will be called as the citrazine. But it causes sometimes, this is less effective. But in case of levocitrazine, you can see levocitrazine only present in the R form. R form means levocitrazine. Okay, no sedation. Okay, another thing is that this levo is more active than citrazine. Remember this, more active than the citrazine. Okay, this also useful for the same runny nose, itching, various allergies. Okay, all those things they are going to be treated. This is the difference between the citrazine and levocitrazine. Citrazine both in both form, R and S form, but this is only the R form, levocitrazine. Okay, it is less active, but it is high active, means more potency. Okay, see, dose also it required more, but it required the less dose. Okay, it causes some allergies. Okay, but it is having the lower side effects. Okay, mild sedation, but in this case no sedation. Okay, and onset of action 1 hour. Okay, sometimes it is faster. Okay, and it is metabolized slowly, but it is metabolized little bit fast. That is the difference between the citrazine as well as the levocitrazine. This here we will be discussed in the next class. Thank you very much. Please subscribe my channel and like it. Then I will provide even notes also for this. Okay. In the next class, the important topic we will discuss the share of the anti H1 antagonist.